Uh, well, thanks for having me. My name is Esam Zahrani, and I'm a computer engineering PhD student at the University of Alabama at Birmingham in the US. My supervisor is Professor Leon Jalalian. Our research interests are in digital forensics and forensic text analysis using artificial intelligence techniques. So today, I'll present our paper titled How Different Text Processing Techniques Using the Bert Model Affect the Gender Profiling of Authors. So, yes, here is the table of contents for today's presentation. I'll talk about the motivation and problem statement. I'm also going to talk about related work and how we use the information from related work to build our experiment. I'll also shed some lights on some limitations we have noticed during our literature review. For the rest of the presentation, I will share our proposed model and its evaluation. Finally, a summary and directions for future work will be given. So, authorship profiling, just a background information to get familiar with authorship profiling. It's the categorization of anonymous text based on author's demographic information, such as gender, age, and geolocation. So some approaches that are used currently in authorship profiling is machine learning techniques, statistical techniques, and some manual techniques from linguists and natural language processing techniques, well, also deep learning techniques, and recently transfer learning techniques. So one famous example about authorship profiling is the Federalist Papers, is the series of 85 essays written by Alexander Hamilton, John Jay, and James Madison between October 1787 and May 1788. The essays were published anonymously under the pen name Publius, so in different New York State newspapers of that time. Okay, so why authorship profiling? So, well, criminal profiling has been established and used in investigations for centuries to help solving crimes. It helps to direct the course of investigation by building a possible profile for a suspect. With the large amount of the text that we have today on the internet, we should find efficient techniques to automate the analysis of the text. So to use the forensic authorship profiling results as evidence in courts, we have to develop an accurate, reliable model. So even though the problem of authorship profiling has been tried by many researchers, we are still far from a reliable solution. So what are we trying to answer here? So first, given the limitation of current methods, can transfer learning apply towards authorship profiling and provide better results? And our main focus for this study obviously is how do different text pre-processing techniques using the Bert model affect the gender profiling of authors? So to answer that, and in order to determine the most common pre-processing techniques in the domain of authors' gender profiling, we conducted literature review in which we have noticed that most of the literature review from author profiling shared tasks organized by PAN. So we considered reviewing PAN shared tasks from 2013 to 2017. We also considered reviewing some individual papers to ensure that we did not miss any common pre-processing technique. So the chart shows the frequency of considered pre-processing techniques based on the literature review. We found that at least 29 papers did not apply any pre-processing technique. So for the pre-processing technique, one of the most applied pre-processing technique is the URLs removal, and it was removed 19 times. Mention tags and hashtag tags removal were removed at least 17 times. So the less common pre-processing techniques are retweets, tags, and stop words removal. There is one technique we wanted to apply that was done once or twice, is the punctuation marks removal. So for the limitations of the current methods, based on our observation and features-dependent models, we have observed groups of researchers using the same model and different features, and yet getting significantly different accuracies. We have also observed that there are a large number of features one can choose from. So it is hard to generalize or standardize an approach. The impact of deep learning on NLP, natural language processing tasks, was insignificant. So unlike the impact on computer vision. So a newly developed technique like transfer learning has not been applied towards profiling the age and gender of authors yet. So in transfer learning, a model will be trained on an labeled large data set, and the same trained model will be fine-tuned to a different domain, typically a smaller data set, and in most cases, the data set will be labeled. So the knowledge that was previously learned will be transferred to the target, or what is known as downstream. In computer vision, the technique was introduced earlier compared to natural language processing. One of the examples of pre-trained model in NLP is Bert model, which is based on what's known as transformer architecture. More information about the Bert's model will be on the next slide. So let's get to it. So in case you are not familiar with Bert, here I'll give some quick brief information about Bert. So Bert stands for bidirectional encoder representation for transformers. So the name suggests that it is bidirectional model in which it considers the context of the text in both directions. So also, encoder indicates that the model uses the encoder part of the transformation, not the decoder. The transformer is the implementation that was also introduced by Google, in which the concept of the contextualized masked language modeling utilized by using self-attention technique or mechanism. So it was developed by Google AI language researchers in 2019, as mentioned earlier. It uses the encoder part of the transformer. So Bert was trained on large data sets, include the textual content of English Wikipedia and also book corpus. So when Bert's paper was published, it shows that Bert outperformed 11 NLP state-of-the-art tasks. So to conduct our experiment, the data set we used in our paper was taken from the author profiling shared task from 2016. The data set was collected from Twitter, and it consists of tweets from 436 authors or users. The total number of tweets is 363,031 tweets for both men and women. So the distribution of the tweets per gender is 149,000 per men and 113,000 per woman. So the data set is not perfectly balanced. So here's our experimental setup for this study. We considered having 5 different cases. In each case, we combine more than one pre-processing technique. So in case 1, we considered 3 different common pre-processing techniques: mentions removal, retweet tags removal, and hashtags removal. So in case 2, we added the URLs removal as an additional common pre-processing technique. In case 3, we added punctuations removal, and the stop words were removed in case 4. In the last case, case 5, we did not apply any pre-processing technique, aiming to examine the effect of that as well. So so this is the general implementation of our experiment. As you can see, we have 5 different cases for this study. However, everything else will be the same for all 5 experiments. The diagram shows the steps we go through every time we want to apply Bert for gender profiling. So as you might know, we have some hyperparameters that can have different values. So for the scope of this study, we were focusing on studying the effect of pre-processing techniques. For that reason, we did not want to spend time experimenting with different values of Bert to determine the perfect values for this task. So instead, we considered one of the recommended value for each hyperparameter that was suggested by the developers of Bert in their paper. For our model, we considered the Bert-based model from the Hugging Face Transformer library. We also ran our model for 3 epochs. As for the batch size, we considered 32. We also set our text maximum length to 100. Finally, we chose 2 to the power of -5 for our learning rate. So those are the results for our different experiments are showed on this table. Case 1 achieved about 82%, and the following 3 cases, as you can see, decrease in accuracy as we added more pre-processing techniques. Interestingly, we have in the last case where no pre-processing technique was applied, the accuracy was the highest. So it was about 87%. So we don't have, at that moment, we didn't have a clear explanation for those results. However, obviously, Bert can use every detail for its own benefit. Bert tokenizer, which is called word piece, does not really understand language. Instead, it divides text into sub-word units. So we were thinking it is wise to do some testing with the Bert tokenizer and show that WordPress can handle texts that are removed by preprocessing. So it wasn't wise to deprive Bert from such information. So to conclude, Bert achieved the best accuracy for the task of gender profiling where no pre-processing techniques were applied. What is considered significant pre-processing technique or other approaches is not as significant for Bert, as Bert is pre-processing techniques independent. Could the findings be generalized for other pre-trained models? So for future work, we would consider adding more demographic characteristics such as age. We would also consider including more pre-trained models. Thank you. And if you have any questions, I'll be happy to